Okay, so yesterday we talked about numbers 1 and 2 on the Toy Car Lab. So for number 1, you made a data table of position and time, and then number 2, you graphed it. So you should be up to this point. If your car accelerated, your position time graph should look like what? It'll be something like this, a curve. Or probably, even better, it'll probably start out like this. It'll probably start out, boom, like that, and then gradually get steeper. Okay?
It actually sort of evens out.
Well, it reaches a constant velocity. Yeah, if your car reaches a constant velocity, then it's going to do this. Because remember, what's the important thing to know on a position time graph? And don't memorize it. Slope. So what's slope? It's rise. What are we measuring the rise in? Meters. What do we measure the run in? Seconds. What's meter per second? Velocity. So if your toy car started from rest and went faster, 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 if the velocity is getting bigger, what's going to be happening to the slope? The slope will be getting bigger. So if your car accelerated, it's going to go steeper, 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 and then if it reaches a constant velocity, then it'll go straight like that, right? Okay, so your graph should look something like this. Okay, now, so I'm going to start with number 3. So I'm going to get you guys totally solid on what you're doing here. The trickiest part is going to be when we get down to number 8. So number 3, super easy. What number 3 says is from the graph you just made, find the position of the car at the following moments. So it wants 10/40ths. So let's say, say like right here is 10/40ths. If you want to know where the car is, the position of the car at 10/40ths, what do? You go up to the graph and what? Over. Boom. That's the position of the car at 10/40ths. Okay, at 35/40ths, let's say right here. Let's say that's 35/40ths right here. You go up to the graph and over. That's what you do for number 3. Okay, number 4. From the graph, determine how far the car traveled during the first second. So how many 40ths is a second? 40/40ths. So for number 4, you're going to go to 40/40ths, go up to the graph, and over. That's going to tell you how far the car traveled in 1 second. So any questions on 3 or 4? Pretty easy, just up and over. Okay, number 5. Now we talked about this earlier. What's today? Tuesday. So it was last week. Last week we talked about how to do number 5. It says determine the average velocity between 6/40ths and 21/40ths. So how do you find average velocity on a position time graph? So let's say there's the graph. Let's say that this dot right here represents 6/40ths. This dot right here represents 21/40ths. Okay, so you got 2 points on the graph.
You draw a line.
How do you find average velocity between those 2 points?
You draw a line between the two.
Connect the 2 points with a straight line, like that. Then you take the slope of that straight line. Now remember, for a straight line, you can use any 2 points. So I would just go like this. There's your rise. There's your run. So notice that this rise right here is the delta x. That's the change in position. From there to there is the change of position. And then from here to here, that's the run. That's the delta t.
Why isn't there a delta y? What is delta y?
Well, delta x is what we mean by position. Good question. Yeah, because look, we have position on the y. But look, in physics, when we say delta x, what does delta x mean? The delta is change, and then x is position. Yeah, kind of weird because we have position on the y. But delta x is change of position.
And there's no x in position.
Hmm?
And there's no x in position.
Yeah. Okay, everybody good on number 4? I'm sorry, number 5? So number 5 wants you to do it, from the graph, and then part B let's see, what does it say? So A wants you to figure out the average velocity using the paper tape. How would you figure out the average velocity between these 2 points with the paper tape? So if this is your paper tape right here, you got these dots, you know, you got these dots. So what you're going to do is you're going to find 6/40ths, and then down the paper tape you're going to find 21/40ths. You're going to get out the meter stick and measure the distance between those 2 points, right? That's your delta x. Measure how far the car went from one dot to the next dot, and then divide by the time. What's the time from 6/40ths to 21/40ths? 15/40ths. So, you know, so basically, you know, velocity is displacement over time. Okay? That's number 5. Number 6, from the graph created at number 2, determine the instantaneous velocity at 25/40ths. So now we're looking at instantaneous velocities. So let's say that right here is 25/40ths. How do you find a velocity when you have only one point? You first do what? The tangent line. So you're going to go to that point. You're going to do the best. Now there's human error here. It's not going to be 100% perfect. You're going to do the best you can and draw in what we call a tangent line. The slope of that tangent line is going to be the velocity at this point. Now, period 4, a kid asked, which 2 points do you use on the tangent line? On this tangent line, which 2 points do you use? Any 2 points, because if it's a straight line, the tangent line is going to be a straight line, so you can use any 2 points on the tangent line that you want. But the slope of the tangent line is going to be the velocity at that point. That make sense? So that's how you do number 6. Okay, number 7. What does the graph from number 2 say about the speed of the car? So for this graph that I have here, what's happening to the speed of the car? It's increasing. Unless you got a graph like this. Some of you might have that. If your graph looks like that, then what's your car doing? Constant velocity.
But it's not possible.
Okay, number 8. This is the one that you really have to pay attention to, and after this I'm done. And you have the rest of the period to work on the lab and the homework set. Okay, number 8. So here's your graph. What number 8 says is, from the graph, pick 7 to 10 values and then determine the instantaneous velocity. From the graph created at number 2, determine 7 to 10 values of instantaneous velocity at times ranging from the beginning to the end of the run. So here's what it wants you to do. This is number 8. You're going to pick 7 to 10 points. So go boom, boom, 3, 4, 5, 6, 7, 8. Just make sure that these points are easy to find times, you know. You don't want this to be like, you know, okay, so this time is 15.3/40ths. I mean, being in 40ths is already tedious enough. Just make sure that these times fall on an easy to read time. So like you want this to be boom, like right on 15/40ths. Have this one be boom, right on 18/40ths. You know what I'm saying? Have them on nice, easy to read times. Okay, now for each of these points, you're going to determine the velocity. So remember I told you yesterday, make this graph big, because if you make the graph little, this is going to be very, very difficult. So I hope you made a nice big position time graph yesterday. So you're going to go to each of these points and find what the velocity is. How do you find the velocity at each point? Well, you're going to go to the first point. How are you going to get the velocity at that first point? Draw in a tangent line. Let's use this. You're going to go like this. You're going to go boom, put in a tangent line. The slope of that tangent line is the velocity at that point. Okay? Go to the next point. How do you get the velocity at that point? You're going to draw a tangent line. Oh, that one's not very good. You're going to draw a tangent line. The slope of that tangent line is the velocity at that point. You guys follow me? And just keep doing that all the way up. And will your graph get messy? Yes, because you're going to be doing like 7 to 10 tangent lines. So to get the velocity here, you go tangent line, take the slope. Here, tangent line, take the slope. And then what you do is you're going to make a data table of time and velocity, right? So you're going to have your times, you know, like let's say you got 2/40ths, 6/40ths, I'm just picking times here, 10/40ths, and then how do you get these velocities that correspond? Tangent line, slope. And then guess what number 9 is going to have you do? Number 9 in the lab, you're going to take this data table and what? Make a graph. All right, that's why I'm giving you guys time in class to do this. This lab's kind of tedious. It is tedious, but believe me, it's a great lab for really understanding position, time, and you know what's happening. It makes you think. You can't get through this lab without using your brain. All right, any questions? Okay, so you got the period. Try to be up to number 8. If you can get to number 8 in the lab, that's awesome. I'll check this Thursday. No, the walk lab I'm checking Thursday, and then homework set to number 15 by Thursday.